It's great to be here as part of the Food Agility Research Symposium. I'm Julia Easton, and I, as Dave said, jointly the project with Mark Gibberd, and we work in the Centre for Crop and Disease Management at Curtin University. The On-Farm Water Demand Project is the second project that's developed as part of the WA node of Food Agility. The project would not be possible without the financial support from Food Agility, Curtin, the state government of WA through GITSI and DPIRD and Swan systems. And we're very, very grateful for the support from the Southern Forest Food Council and the farm businesses that have been so generous with their knowledge and data as participants in the project. And our collaboration with the Department of Water and Environmental Regulation is also gratefully acknowledged. So this project is industry driven. We have had a long partnership with Southern Forest Food Council, and at the start of the project there were community tensions developing around water allocations in the Manjimup region of WA, and this is the challenge between water for agriculture versus environmental flows. So Southern Forest reached out to Curtin to help them to develop a digital evidence base for the value of water for agri-food production in the catchment. The primary reason for doing this is it's not possible to value the water in the absence of accurate water use and the dollar return data. And the water demand for on-farm production is generally collected by farm businesses, but not by government departments, whereas water supply is. So if Bevan wants to know how his vegetable crops will stack up in terms of dollars per megalitre against other crops grown in the region, which crops will his son be able to grow profitably in 10 to 20 years' time? And will he have enough water to grow them? So the Warren-Donnelly catchment is based in the southwest of Western Australia. It's quite a large area that has a mixture between agricultural forest and agricultural land and forestry land, and a lot of the areas have been fully allocated or are close to allocations. An overview of the project: we have 27 participating farm businesses from within the catchment, and this includes the crops avocados, apples, truffles, potatoes and wine grapes. We have at least 5 sites from each commodity, and they're representative in the region either for tonnes or dollars from a market point of view in the case of truffles, or they're a low water user in the case of wine grapes. We've spent an awful lot of time working with the farm businesses to support them to use the data to help them make decisions about irrigation, but also about the seasonal planning. And we've found that the alignment of the financial data to drive adoption for digital tools and decision making has been really useful. There's an element of peer-to-peer learning. We've run a couple of facilitated workshops to support farmers to learn from each other and to benchmark their own water productivity in terms of tonnes per hectare and tonnes per megalitre, and their profitability in terms of dollars per hectare and dollars per megalitre. And we're taking these raw data sets and scaling them up to the whole of catchment to be able to estimate the value of the water for agriculture in the catchment and the following on triple bottom line benefits for the community. The research framework for the project includes 4 major areas. So we have raw data collection around applied irrigation. This is measuring irrigation volumes to get a calculation for water productivity. The project's coming to the end of its first phase and beginning the second phase. So we've got 2 full seasons of data, and we're looking to capture 2 more through the second phase. And this is all spatial point data that we're going to scale up to regional crop distribution. We're also estimating water profitability and productivity. So in order to do that, we need to understand the production and the production costs and some of the farm overhead costs to get an idea of profit. This is agribusiness data that's collected using a similar framework to some of the farm management consulting groups in the region. And again, this is point source data to be scaled up. In order to calculate crop evapotranspiration, we can use lots of calculations, but we need to understand the crop distribution throughout the catchment. And we've developed some tools to be able to estimate the current plantings, which I'll talk about a bit later. And we've done the first phase, and we'll move into the second phase going forward. We also want to think about future scenario modelling and what might happen in different climate scenarios or different circumstances in terms of crop plantings or changes to water availability, and we'll be doing that across the catchment under direction or under input from the industry drivers and the state government drivers for understanding these challenges in the region. And as I said, we've got the 27 participating farmers. We've got one block for each one of them, ranging from 1 to 5 hectares. They're representative. The irrigation data collection uses off-the-shelf equipment that's provided to the project through WildEye. We've got a paddle wheel flow meter, we've got moisture probes, and we've got an IoT-enabled logger. We also collect the crop production data in terms of yield of the raw crop and the financial agribusiness data, so revenue, operating costs, farm overheads. And then we can bring all of these pieces of data together to be able to present some of that back to the individual farm businesses and also for the industry-wide information. So the kinds of data we collect from the loggers are quite complicated. So we've got the soil moisture measurements in red here. Green is the irrigation, green bars are irrigation, blue bars are the rainfall, and there's lots of orange dots in here, which is evapotranspiration. And then we can draw that into visualizing monthly site observations. So where we've got the irrigation in dark blue plotted against rainfall for each of the months. So starting from July and going through to June. We work on financial years because that's how the financial data works, and it makes it a bit more simple. And it also makes quite a lot of sense from a seasonal point of view. The yellow bars here, so this is an example from avocados. So this is the estimated crop water demand, and it's plotted against the evapotranspiration for each of the months. And we've found that this piece of data is really useful for that end of season review and to talk to the farmers about what happened in each of the months. So for example, in this particular month, there was this November, we had a very high rainfall event in November, so the irrigation was a lot lower, and then the total water exceeds the crop water demand, whereas in December and January they were about at water demand, and we had a similar event in February where we had a high rainfall event, so it pushed it over the monthly water demand. And the key piece that we want to be able to bring to the table is water productivity. So how many tonnes per megalitre for each of the crops. So we can get the stretch of the cohort of farmers that we're working with. We're really keen to get the breadth of approaches rather than a narrow, tight set of information, because we want it to be representative of the kinds of farms and the kinds of production systems that are in the catchment. And then when we bring the agribusiness data together, we're also looking at what is that stretch of water profitability for each of the commodities, and then to be able to look at the commodities to compare them together. So again, this is a similar kind of example to the one that I just talked through. We've got each of the months along the bottom. This is crop water demand in the yellow by month. We've got the irrigation stacked on top of the rainfall, and we've got the evapotranspiration for each month. And this is a different season to the other one, but again, we've got quite high rainfall in October and again, rainfall in May, but over the summer period, it was, we didn't have any large rainfall events for this particular site. What we've been able to do is for each of the, I've lost my other parts. Okay. What we've been able to do for each of the sites is to plot the monthly values against each other. So you can see so we've got months along the bottom here. The irrigation is on the left, evapotranspiration's on the right. So evapotranspiration's the yellow dots, and each of the different green coloured bars represents the individual farm businesses. So you can see that there's some different strategies. So some of them are going much lower and some of them are going much higher, and then we've got a group in the middle. And so again, it's really great to see the breadth of approaches, and then when we all come together and talk about, well, why do you do it like that and why do you do it like that, then there's some really interesting discussions that come out of that. And what I want to be able to get to is to have the box plots that show water productivity and water profitability. And I think they're actually hiding behind my my visualization there. This is the last season for apples. Again, we've got months along the bottom, evapotranspiration on the right, irrigation on the left, and the individual different pink coloured bars are the different farms, and evapotranspiration is plotted in yellow. There's one site that has sprinklers, and all the rest of the sites have dripper irrigation. So that shows the difference in water savings when you're using drippers for apples, but there's a big tight bunch in this month here together. So, and we do see a stretch in the water productivity across the cohort of farms, and we're still bringing together the agribusiness data. And again, these are similar to the last graph, but the blue lines are the truffle farms, and again you can see some of the individual different approaches and strategies. And the potatoes are really interesting because they only run for 12 weeks and they have a staggered start. So each of the farms are planting at a different time of the year. So planting earlier means that you're using less water, because in this particular season it wasn't so hot. If anyone's from Perth and remembers back to what Christmas and January and February were like, you can see these early plantings had very, very high water application, really to just keep on top of the weather at the time. And this graph shows why we've decided to incorporate wine grapes into the project. They're very, very low water users. It's a little top up at the end, and it's really interesting to see how their financial data and their water productivity and profitability play out against how much is applied. And also this becomes important in the future. If the rainfall and runoff reduces and perhaps the evapotranspiration demand increases, then the need for wine grapes to have more water applied will be evident. So one slide that's taken 2.5 years to pull all of the data together, and we're still waiting for information to come in. So we've got, for each of the crops, we've got avocados, apples, truffles, wine grapes and potatoes. And then I've got, at this point in time, just mean, min and max, because we don't have the complete data set, and we really do expect that these numbers will change. But you can see the difference in tonnes per hectare. So apples, we get much higher tonnes, and that's lines up with the production data that we get from the government. Truffles much lower in their production, but the price that they receive is much greater than the other crops. The interesting thing is, from a megalitre per hectare usage, we've got quite similar numbers. And this is stretched over 2 seasons, but similar numbers between avocados, apples, truffles and potatoes, really not the big differences that we're expecting. And then again, seeing the wine grapes really quite a lot lower than everything else. And then we can start to estimate tonnes per megalitre, and there's big differences in those. And then we can start bringing the financial data in to get an indication of dollars per megalitre. And again, really waiting for to finalise that data set. Last year, we presented Stan's work on the crop classification and distribution. So this is just a reminder that this is a key part of the activity. If you're interested in this, you can go back and watch the previous presentation. But we collected training data from 631 crops and land use blocks identified through our farm businesses that we're working with. This became a really valuable data set. We collected crop type, age and variety, and where in space they were located. And Stan uses 2 years of cloudless optical data from Sentinel-2 and synthetic aperture radar from Sentinel-1, and also captured NDVI and specific leaf area indices. He used machine learning model, a random forest and the CNN approach, and then took the best from that to create a current estimate of crop type and distribution within the catchment. And here's some of the output. This is some close-up versions here, and then scaling out to the whole of catchment. So it's really interesting and powerful piece of work and raw data for the project. So Dave asked that we talk about our Gnarly to Eureka moment. So as Dave alluded in the previous presentation, the Gnarly part is always in the primary data collection. And, you know, we've heard today that this is always a challenge. From our point of view, there's ways that you can reduce and minimize the challenging part, but it takes time and it takes effort. So it's multiple touch points with project participants and building trust, particularly when they're sharing financial data and not sharing any of that information with anybody else. Really redefining the clear value proposition from an individual point of view and an industry-wide benefit for why they might share the data and what we might do with it, what they can do with it, and what the industry can get from it. And having a simple reporting system and really supporting the farmers in collecting the raw data really helps to streamline the future collections, and that's in particular for the financial data. Our Eureka moment, the value of the raw data set that we've had is so valuable for the industry, and the 2 state government departments that we've been working with are really excited about actually having real data to use that's defensible and independent. Yeah, again, independent and defensible data on the water for agricultural production. And in the last 6 months or so, our project has evolved from industry involvement to industry demand. And that's really exciting. I'm looking forward to the next 2 years. And finally, the utility of this data for future scenario planning in terms of changes in land use, crop type and climate, etc. I think we're on the verge of starting to build that piece of work. So hopefully I'll get to report that that's a Eureka moment for next year. Finally, I'd really like to thank all the project team members, but particularly the farm businesses and the Southern Forest Food Council that we work with. Without the generous knowledge sharing, time, effort and support that we've had, we wouldn't be able to be at the place that we are. So thank you so much for that. And again, there's a huge list of people to thank. So I'll leave that slide open and say thanks.
Thanks, Julia, and the project team. It's a massive project, and a bit of a plug too to the team, because Julia's comment about the challenges around sourcing primary data. Early in the early days of the CRC, we thought long and hard about maybe as part of the project build and part of the proposition creation that a data audit be done before a project get approved and funded. We threw that out because of the very hard lessons learned by the on-farm experimentation project and this one. Some of the projects have been with us since day one. Why? Because at the end of the day, you kick the project out the door and this stuff just happens and everyone really rolls their sleeves up and mucks in and we all learn together. So we've learned a lot from the Curtin team, Julia and Mark in particular, in relation to the importance of that data. And the fact is that you just press on regardless. And
Thanks, Dave.
So,
well, if I can add to that, I think the approach that we took with this project, starting with a few farms, so we started with 5 farms rather than doing 27 and made all the mistakes in the first year with the 5 farms and learned, it was really great because the people we were working with were very patient and understanding, but it meant that when we scaled up to, because it's a big ask to try and get to 27 farms and collect the farm management data, and but we did the hard yards on a small subset, so we didn't make the mistake 27 times.
Yeah, absolutely. So anyway, I've got a couple of questions that have come in, Julia and team.
Okay.
Now, you in the slides you're referring to in those wonderful histogram almost looking slides of the water use values, you've got evapotranspiration there. Is that the ET reference value or is it the actual ETA value? Can you recall?
ET a reference value, or is it calculated? I can't remember what we did. It's calculated.
Right, thanks, Mark.
He's sitting here in case I don't know the answer.
I've got a glimpse of you moving furniture around at the beginning. So
sorry.
Thank you, Mark. Appreciate it. Another one, you know, when you put up those hard-earned data points around water values and recognizing, you know, you've got a mean value and you've got a maximum min, and there are some really big ranges, but of course that's the farm. Absolutely. Anyway, those values in general, any pleasant surprises, nasty surprises? What was the industry's first response when you put those very first numbers up to them?
I think it depends on where they sit on the spectrum, right? Well, for the farm participants, so I think the people at the top of the list are kind of do a little, oh, I'm kind of excited about that, and I didn't think that I'd be at the top of the list, and they're all very humble, and you know, I think it's very seldom when you work in a farm business that you actually have a measure of your performance in the same way that if you're working in an organisation and you know how you're performing against other people. So I think, and that's part of having to have that trust for them to be able to share their most precious and sensitive data in the financial space. A couple of weeks ago, there was an open forum in Manjimup because there's a few changes that are happening with the Southern Forest irrigation scheme, and there was an open meeting and we were asked to present this data, and we got some really great feedback from the wider group of farmers in the region, and there was lots of support for the collection of the data because they recognise how valuable it is in whatever we're going to do going forward. So that's pretty exciting.